Okay, for this last lesson, we're going to take a look at solving radical equations. So the first thing we're going to do is we're going to graph it out to see what it looks like. So I'm going to graph in my calculator y is equal to the square root of x. And then when I plot the points from my table, I start at the point of 0, 0. And I get 1 and 1. And then I get 4 and 2. And then it's just going to continue on this pattern, stretching out like this. In this case, what is the domain of this graph? Well, it's never in the negatives, which means that x has to be greater than or equal to 0, where x, e, r, and make sure we include those set brackets. For what values of x is a radical expression defined? When it says defined, it means when is it actually possible? Well, it's possible as long as x is greater than or equal to 0. And we know this because we can't take the square root of a negative, so that makes sense. If I plug into my calculator y is equal to the square root of x minus 2, then when I take a look at the table, I start at the point of 2 and 0. And then I have 3 and 1. And then I'm going to have 6 and 2. And it's going to spread out like this. Keeps the same shape as my first one did, but everything is moved 2 to the right. What's the domain in this case? Well, x has to be greater than or equal to 2 in this case, in order for it to be possible, where x is an element of all real numbers. If I'm stating the restriction, I'm saying, well, when is this actually possible to solve? Well, it's only possible to solve if x is greater than or equal to 2. If x is less than 2, I'm going to get the square root of a negative, which is going to be not possible to solve. If I have to solve this algebraically, well, I know what's inside the square root, x minus 2, has to be positive or equal to 0. Which means that when I isolate x, I'm just going to move the 2 to the other side, and x is going to be greater than or equal to 2. If I'm graphing the last one, where it says y is equal to 3 minus 2x squared, or sorry, the square root of it, then in this case I get 1.5 and 0. And then it's going to be some decimals coming through. Coming backwards, and it's going to stretch back like this. What are the restrictions on the variable? Well, x in this case is going to be less than or equal to 1.5, which as a fraction would be 3 over 2, where XER. I'm still going to have the same rule that I had in the last case. I still need to say that what is inside of the radical has to be greater than or equal to 0 in order for this to be possible. I'm going to subtract 3 from both sides, and negative 2x is going to be greater than or equal to negative 3. Here's the thing you have to be careful about. Anytime that I divide or multiply by a negative, if I have an inequality or if I have a greater than or less than sign, if I multiply or divide by a negative, the direction of the sign changes. Which means that x is going to be less than or equal to 3 over 2. So remember, anytime you multiply or divide by a negative, the sign changes direction. A radical equation is an equation which contains a radical. A value of the variable which satisfies the equation is called a root. In this lesson, we're going to learn how to solve these. So, the first thing is I need to determine any restrictions on x. Well, that means that I'm just looking at the radical, and I know that in order for it to be possible, the radical has to be, or the radicand has to be greater than or equal to 0. So, x minus 2 has to be greater than or equal to 0. The one on the outside doesn't matter. It's only values that are going to make the radical impossible that we have to worry about. So, x is going to be greater than or equal to 2. In the second case, 4x plus 1 has to be greater than or equal to 0, which means 4x is going to be greater than or equal to negative 1. And when I divide by 4, x is going to be greater than or equal to negative 1 over 4. I wasn't dividing by a negative, so the sign stays in the same direction. In this case, 2 minus 5x has to be greater than or equal to 0, which means negative 5x has to be greater than or equal to negative 2. And when I divide by negative 5, remember to flip the direction of the sign, which means that x is going to be less than or equal to 2 over 5. In the last case, there's no restrictions. Why is that? Well, you can take the cube root of a positive or a negative number. So because you can take a cube root of a negative, that's possible as well. There isn't any limitations. If I'm solving these by graphing, if I have the radical equation, the square root of x plus 1 is equal to 4. Well, first off, the value for x, which the radical is defined, is going to be when x plus 1 is greater than or equal to 0, which means x has to be greater than or equal to negative 1 for this to be possible. Next, when I'm explaining how to use a graphing calculator to find the solution to the equation using the intersect feature, I'm going to say that the left side is going to be y1. So I'm going to put for y1, it's going to equal the square root of x plus 1. I'm going to say that y2 is going to be the right side of my equation, or y2 is going to equal 4. Then I'm going to either use the second trace and number 5 for the intersect, or if you're on a Casio, it is shift F5, F5 to see where these lines cross. I'm going to have my first line is going to look something like this, where it starts at that negative 1 and is going to stretch out like this. I'm going to have my second line, where y is equal to 4, is just going to be this horizontal line looking like this. And if I drew it a little nicer, then when I solve for where they come into contact with each other, it happens at the point of 15 and 4. So what's the solution to the equation? The solution to the equation is when x is equal to 15. If I'm proving this works algebraically, I'm going to substitute bracket 15 into where x was, and say that the square root of 16 is equal to 4, which means that 4 is equal to 4, to prove that it works. We also need to be able to solve these algebraically. So in this case, because it's already isolated for the square root, I'm going to square both sides, which means that from what we have experienced before, if I take the square root of something squared, it cancels out the square root, which means that this would just become x plus 1. And 4 squared is going to be 16. If x plus 1 is equal to 16, when I subtract 1 from both sides, x is equal to 15. And obviously, we've already done the verification on the other page. The square root of 15 plus 1 is equal to 4. The square root of 16 is equal to 4. And 4 is equal to 4. Now, like I said, when we're doing it, in the last case it was already isolated, but we always need to isolate the radical before we start. So the first thing is, if I had this equation, we're going to subtract the 3 from both sides. Now, when we subtract the 3, we have the radical by itself, and we're going to square both sides, remembering that's going to cancel this out. But now we have a binomial we're squaring on this side. So you have to be careful. Remember that even though this is still going to just become x minus 1 and it's going to cancel that out, this is the same as x minus 3 times x minus 3. It's not just x squared and negative 3 squared. X minus 1 is actually going to equal x squared minus 6x plus 9. Make sure you multiply that out properly. I'm going to move everything over to one side of the equation. 0 is equal to x squared minus 7x plus 10. I can factor this, and x minus 5 and x minus 2. So x is going to equal 5, or x is going to equal 2. Now I need to double check and see if this is true. So when I'm checking to see if it's true, I'm going to do my verification process. 3 plus the square root of x minus 1. Well, let's try the 5 first. 5 minus 1 is equal to 5. 3 plus the square root of 5 minus 1 is 4 is equal to 5, and 3 plus 2 is equal to 5. 5 is equal to 5, so that is true. Let's try the other possibility. 3 plus the square root of 2 minus 1 is equal to 2. 3 plus the square root of 1 is equal to 2. 3 plus 1 is equal to 2. 4 is not equal to 2, which means that that is incorrect. X is equal to 5 is the only solution. If I graph this out in my calculator, in order to confirm these, I'm going to graph y1 is equal to 3 plus the square root of x minus 1. And I'm going to say that y2 is just going to equal x. And when I solve for when they cross, they only cross once, when x is equal to 5.